So good afternoon. Yes, I want to talk about orchestration of microservices, and just to avoid any confusion, I'm not talking about like container orchestration like with Kubernetes. What I want to talk about is if you're taking like a bunch of microservices, I actually don't care too much about how micro they are. So they might be really microservices. It might be like several components, let's say. It might be even serverless functions. So there are a couple of ways of slicing functionality into like different components. But I want to have like different components, and what microservices normally promise is some kind of, okay, they're owned by a certain team, they have their own data. It's normally like an own process. So if you think of it like from a Go perspective, there might be like really several Go processes going on there. So that's the setting, and I want to talk about how these services can basically collaborate in order to get something useful done, like communicate basically. Okay, does that make sense? I hope that's okay. What do you expect? Great. As always, I mean, I'm a human being, so I'm obviously opinionated in a way. I just want to make it transparent so you can judge for yourself. So my opinionation is basically that I've worked with workflow engines since my whole professional life, basically. So I contributed to a couple of open source workflow engines in the past. Over the last 10 to 15 years, I worked in a lot of customer engagements around that for various clients, starting from like things like Lufthansa or T-Mobile to AT&T or Zalando, whatever it is. And in my current role, I co-founded the company, and I'm developer advocate. So I'm traveling around, giving a lot of talks, doing a lot of blog posts, but also doing a lot of solution design things. And I'm obviously looking at problems from the, let's say, the workflow engine perspective, let's say the state machine perspective. So what I see in a lot of these challenges customers are currently facing is that some of them can be really addressed by or need state in order to be addressed correctly. And that's basically also what I want to look at today, okay? So that's basically setting the scene. So, and I love doing code, actually. I'm a guy who understands concepts when he sees some code to it. So I want to show some code, I want to go through some codes, and therefore I have to use a framework, by coincidence, the one from us. That's an open source framework, CB. It's in the web, but there are other frameworks out there which are really comparable. So my focus today is on the core idea, on the concept. Pick your tool afterwards, but I want to use them in order to show code. And actually, the problem, so to jump into the topic, one of the things we see out there happening, if we have these services basically collaborating, one problem, and that's just like one example, is that if one service has a problem, that's perfectly fine, and that's a shift in mindset. So we start to accept these kind of problems. So either it's a network which is faulty, or the service is probably down, or whatever it is. So we have to accept that some services might be out of order for some time, but we have to avoid that this gets a cascading failure, brings down the whole system, right? That's like the resilience topic. So that's one problem we face in distributed systems currently in microservice architectures. And I want to look at that with one example. And I love stories, so that's a little story which I experienced myself. So who used an airplane before? Okay, that's a safe question to ask. You're familiar with the process. So you book a ticket online, and then you're like 24 hours before the flight, you get an email invitation, please check in. Then you go to the website, you select the seat, you say, okay, I accept all the whatever weird things you want to have, and then you get like a seat is selected and the boarding pass, right? You want to have a boarding pass to go to the airport. I did that for a flight like 1.5 years back, I think, when I started doing these kind of talks. In this case, it was a flight to London with Eurowings. I flew from Germany, so it's a German website, sorry for that, but it's very easy to get, so I could check in, that worked. But then when I clicked the get my boarding pass thing, it said me, okay, there was an error while sending you your boarding pass. Okay, yeah, whoops, that shouldn't be that way, right? I have no idea how Eurowings really works underneath. We have customers which do comparable things. So I envision it like this. So it was me in front of the browser. Then there was a web UI serving the whole web page. It probably used a microservice which does the check-in. And in order to issue a boarding pass, for example, you need these nice little 3D barcodes on the boarding pass, or a PDF if you want to print it out. And that's normally like done by upstream services. So I think there were other services involved, like the barcode generator or the output management. And I think that some of these services might be broken, because I could check in, that worked pretty well, but I couldn't get the boarding pass. And that's what I mean, that in a distributed architecture like microservices, we should accept that this will happen sooner or later. We cannot avoid that. It's too expensive to avoid these kind of problems. So we have to live with it. But what they actually did is they basically transported that error, the whole chain upwards towards me as the end customer in this case. And that's a bad design here. That's a really bad design because what could I do about that? What would you do if you have this kind of problem? We're programmers, right? Have you tried turn it off and on again? I hit F5 or something like that. Of course, you retry it. That's like a built-in reaction. So you retry it. It didn't work. I retried it like 5 minutes later or 3 minutes later. It still didn't work. So what I did next is I create a calendar entry in my Outlook for reminding me like a couple of hours later to send me the boarding pass because I forget these kind of things, all right? So there was a beer, so I forgot. So I make me a calendar entry which is persistent. So what I did is what I call a stateful retry. I retry it, but it has to be stateful that I don't forget to do it. In this case, I use my own persistence, which is my Outlook. But Outlook makes sure it's there. It's persistent in the cloud somewhere at Microsoft. Okay, so that's a stateful retry. But it's a bad design. I actually shouldn't do that. I mean, the best part of that story is actually that really, and it's true, it was my onwards flight from London, not with Eurowings, with EasyJet this time. And EasyJet had the same problem. They have a different error message, and I'm not sure if it's readable in the back, so I go through it. We were having some technical difficulties at the moment. Yeah, I recognize that. Please log on again via EasyJet. Okay, retry it. If that doesn't work, please try again in 5 minutes. Okay, please. Oh, yeah, you got that. But I mean, they give me the work instruction. That's already pretty good, right? And the next thing is best. We do actively monitor our site. We'll be working to resolve the issue. There's no need to call. It's really your problem. Sort it out. We don't care about that. I mean, they really say that like that. And that's bad. I mean, they have a technical problem. I understand. I mean, I'm a programmer as well. I totally understand that. But they have the problem, though. They should fix it. And I mean, it's a boarding pass. It's asynchronous anyway. I want to have it like on my mobile whenever I enter the airport. They can send me an email whenever it's OK, right? So they should say something like, we are having some technical difficulties. Yes, but we do actively retry ourselves. So lean back, relax, we send it over. Right? That should be a reaction. And in this case, I mean, it's very obvious because it's kind of a customer-facing situation. But we do the same thing every time, or a lot of times within organizations in service-to-service communication, like other services which might be just upstream programs, upstream services consuming us, and then we just hand over errors. So I see that happening all the time. What would be better? I mean, in this case, it's easy. It should be, the stateful retries should be within the check-in service, for example. And then you don't have to cascade it all the way up through all the other services. So it should be relatively local. It should be in the check-in. Then the check-in can send me an email whenever it's ready. Then it's much more resilient. I don't care when the barcode generator doesn't work, right? That's relatively obvious in that example. The problem normally is that I called it stateful retry. And I mean, it's very obvious as you read through like blog posts or probably listen to like serverless talks earlier on, that we are moving towards a stateless world. So state is kind of a bad thing to have, right? And that's why, and obviously it's important to do that in order to avoid this cascading failure. So, but state is kind of a, all right, change the slide order. I'm sorry for that. And we're coming back to state in a bit. Sorry for that. But the other one is, I want to tell the other story as well. So keep in mind, state. We're going to do it stateful, and then we're getting back to that. Sorry for that. And doing this kind of retries, even in a stateful manner, by the way, is a very much a business decision. So it's not a pure technical thing if you want to retry it. Like in this case with the boarding pass, it's like, if you want to send it asynchronously, for example, you have to define a timeout when it's still OK to send it. Like 5 hours before or 4 hours before, people probably start getting nervous if they haven't sent it yet. So you want to do something about that. It's a business decision. So if you start introducing this kind of state, you're normally also moving towards these kind of business decisions. Speaking of retrying, I want to tell a second story, which is, I think, quite important here. I like that story. And I'm really curious how it works actually in Italy, especially in Italy. So behold. No, but I had a vegan part in my life, like a couple of months. I ate vegan like a couple of years back when I didn't have kids. Then you can do this kind of thing. So we ate vegan. And there's an awesome dish. I really love that dish. So you can make like noodles out of the zucchini. There's a special slicer for doing that. Then you add some sauce, and it's really tasty. I totally recommend that. I love that. And in the cookbook it says, okay, if you eat the zucchini, you can eat as much as you want because it's basically you don't grow fat. It's not unhealthy. You can eat as much as you want from the zucchini. So I use the zucchini as a metaphor for idempotency because if you ate your plate of zucchini, you can just eat another one. If you forget it again, you eat another one. So eating zucchini is idempotent. Eating pasta is not. And that's speaking of retries. And if you only want to remember one thing from the talk, I think it's probably best the zucchini because if you want to do stuff like retrying, what I did earlier on, what you need to have is that the service on the other side needs to be idempotent. And idempotent means that you can call it twice without getting a problem. So if you do retries, you probably call it twice. And that should work. I give you an example with, I do a couple of payment examples in a minute, like in the live coding. So if you have the payment, for example, and that charges an upstream credit card service, that's the example we will do in the demo. Then you can have like an API where you say, okay, charge the credit card with some data, which is not idempotent, or add some transaction ID, or correlation ID, or trace ID, or these are typical names for these kind of things. As soon as you add that, it's idempotent. You can do it again, because the service recognizes, oh, I already did payment for you. And that's super, super important. So, and that's one of the biggest problems we currently face in some microservice architectures. If the services are not idempotent, retrying gets really clumsy. Okay, so if you just want to take away one thing, if you do a service, do it idempotent. That's really important. But then, now we're moving towards state, actually. What do we do in microservice architectures? We basically build a distributed system. And that's what we start to do in basically all over the place. We do distributed systems. And I use that metaphor for distributed systems. So like the small hut over there, that's one program. That's probably your Go program. You depending on what you do there, you probably have ACID transactions. You know what threads are currently doing. And you have a lot of control what's really happening. You understand what's happening. And it's relatively cozy to be there as a programmer. But whenever you open the door, then that's the network, the rough ocean. And there really weird things will happen. And you probably know the fallacies of distributed computing. If not, that's another takeaway which is important to have in mind. And they're relatively old, but they're totally true. And the first one is the network is reliable. That's a fallacy. Of course, the network is not reliable. Have you ever used Wi-Fi? It's not reliable. Even if you have a cable in your data center, it's not reliable. The network will trick you. And that means you have to plan for the things. You have to keep them in mind. And that makes the retrying, for example, even in a case where you just want to call an upstream service via REST API, stateful, because it might not be available. It might not come back for another, 30 minutes. So you have to retry, and very often that's stateful. And now we're coming back to the states. That's what I wanted to talk about earlier on. So handling state. And handling state, I mean, it's 2018, so handling state shouldn't be that hard. We have a lot of possibilities, so I normally call it persistent thing to abstract from that. It might be an entity, it might be a database table, it might be a document store, it might be persistent actor if you fancy that. So I don't care, actually. It's something you have under your control, you persist it somewhere, and you can load it later on. That's persistent. The thing is, if you do that for these kind of problems, you start to have like a list of new problems you have to solve. For example, for the retrying, you have to have a scheduler in order to retry it. You have to do that at scale. You probably have, you change things, how the retrying works, and you still have ongoing retries, so you have a versioning problem, and so on and so forth. So there are quite a lot of problems you have to solve, which normally the people start to sense in the project, so they back off that idea of doing the persistent retries. And then they just throw the error to the next service. It's your problem. It's your problem. And that's not a good idea. There's a class of tools which is really good at state handling, actually. These are state machines. And there are a couple of like really raw state machines out there, but most of the tools I know are really marketed as workflow engines. And I want to look at how this could work. And I use CB, what I said earlier. It's open source. You can look it up, cb.io. You can just play around with all the code I have today. I want to use that as an example. I come back to why in a minute and how it works. But this is the basic idea. So you have your own application. That might be your microservice. It might be a Go project. In this case, I'm using Go, obviously, because you're at the GoLab. Then there's a broker, which is a core workflow engine. In this case, in CB case, that's written in Java. And probably to answer questions which I normally get, I don't know a real workflow engine written in its core in Go. So far I haven't seen that. So the idea is that this is still in Java, but it's easy to fire it up. You don't have to care about that thing. But then you have a client like a JDBC driver. Java. Said Java, now I say JDBC, but kind of a client library just to connect to the broker from your Go code. And I show that in a minute. And then you can define like workflows, and I come back to that, what that has to do with the stateful retry thingy. Like workflows, define that within your source code, and I'll show that in a minute. And then that's deployed on the broker. And then you can run instances of that. So you can say, OK, I want to run one instance of that workflow. And then there are a couple of like services involved. Like, for example, in this case, I say, hey, do service A. And in order to do that, I need some code, and that's basically Go code, which is, again, defined in your application. And then you subscribe to the broker and say, I could do A, I could do B, whatever it is. OK? That's the basic idea, and I show you that in code. So hopefully that's like some people are liking the visual more, some people the code, so I hope that fits everybody. You will get the slides later on, so there's a link. Everything is on GitHub, so you can just play around with the stuff yourself if you like. So let's get going. What I have, is that readable in the back? Kind of, OK, that's good. So what I have is a actually very easy setup. So I have I call it Stripe fake. So I have a fake server running, which simulates to handle credit card payments. It's just a REST API, so I don't care about that at the moment. And then I have like a very simple payment service, which basically just starts an HTTP server, listens to a put method, and then what it does is pretty simple, actually. It charges the credit card. It calls the upstream service. And it does that by doing a synchronous HTTP call, right? So that's it. That's the basic idea without anything else. You know code like this, probably. I see some people at least nodding. So I have this running here. So that's my Stripe. That's my payment. So what I can do next is I can send, I use curl in order to put some payment request on this service, OK? So nothing surprising in the first place. So I get the request on the payment part, and this calls the upstream Stripe service. That's so fine, so good. What happens if I stop this fake service? It might be also that the network connection has a problem. What happens? Relatively easy question to see if somebody is still listening. It fails. Yeah, that's a good thing. So I get a 500 here, right? It fails because this one basically cannot reach the target machine, so it fails, obviously. And that's starting to be that cascading thing. If you now have a call chain of multiple like REST calls, it ribbles up the whole stack. And that means all of the services start to be down. So what can we do about that? So the next version, and I have a couple of versions. I don't go into all of the versions. So the next version is V3. V3 does the thing a bit differently. So I still have my HTTP server. I handle the HTTP request. I charge the credit card. But what I do when I charge the credit card here is I create a new workflow instance of that payment V3 workflow. I'll show you that in a second. And don't bother too much about the API. We improved that in the current version, so it's a one-liner, how it should be. And then I'm basically done here. What's that workflow? The workflow, by the way, it's defined here. It's a so-called, it's BPMN. Does anybody know BPMN by chance? Just to check. Oh, a couple of people actually, okay, but not much. BPMN, it's an ISO standard to define workflows. That's language, let's say. And it's an XML file. So this is how it looks. Don't look at the XML file. There are graphical modelers which can do that. So, whoa, sorry. So this is my workflow. It's a very easy one, actually. I started, then I do something like charging the credit card, and then I'm done. And what you can see already, I can define retry. So the retrying is there. It's stateful because I'm using a workflow machine, which is stateful. And I can define here a type which is called charge credit card. And if I go back to the code, what it does is basically, there's an init CB there. It defines a so-called job subscription. It says, okay, for that charge credit card, whenever this is due, I don't go into the details, just the idea, then use that method. And what it basically does, it stuff a bit of data handling, but then this does the HTTP call. And the HTTP call hasn't changed. So the idea is we move that logic just behind the facade, let's say, of the workflow engine. Okay? And that's it. It's not much more code. So that's basically it. If you want to see the details, just look it out on GitHub. And what I do is I go to V3. I just run that one. Yes, of course, I want to do that. So that's up now. I leave the Stripe service down for a second. So now the behavior changes. I still do a put. I do that. I see a 202 accepted. That's new, not a 200. So 200 means I'm done. Here's the result. 202 means, yeah, I got it. I take care of it, probably later. What you can see here in the background is that it does a couple of retries. Like you see it 1 time, 2 times, 3 times. So it does these kind of retry thingy. But it still doesn't get through. And what you normally have, I mean, it's a state machine, so you can look into that. So probably with some kind of tooling, that depends on what you really use, what kind of tool. And if I look into that, I see, hang on a second. I thought I have a new version 3, which is currently running. Not sure if that's synced. But you can see where currently instances are and where they are standing and what they are still doing. And you could even like trigger new retries for things that are going on. So that's the stateful thing in the background. So there you have a state machine. Okay? Make sense? I come back to that, why that's important in a second. And then you can do even like, yeah, more interesting stuff like this. So you could also like define something based on the payload, like in this case. I base some decision on the payload, and then I either charge the credit card if I still have to, or probably customer had enough customer credit to already did it. And then if you run these kind of things, by the way, I'm not going to that, but you get a lot of audit data by the tools as well, where you can look into like what are typical paths, what are slow paths. I mean, in this case, everything is local, so 0 milliseconds, but sometimes it's probably interesting that you have an SLA on 20 milliseconds or whatever it is. So this is basically what you can do there. Okay, that should give you, my idea was to give you an impression how that works and how complex it is. And now we have a state machine, actually. And why is CB in that case, or what's special to CB? So the first thing, we have a native Golang client. That's, I think, pretty cool. But the other thing that's really interesting, we're currently, we're really building that for scale. So if you do things like what I just did, like doing that for every REST call, we have customers currently doing like 15, 20, 30K, like 30,000 calls per second. That's normally where people think, but you cannot do that with the workflow engine. And that's what we currently do with the CB. So you can do that. We're making sure you can as well like scale up your service, your microservice, like the client, but also scale up the broker. I don't go into details of that. So if you're interested in that, just approach me afterwards. It's basically we're leveraging event streaming underneath, and we're having an own peer-to-peer cluster using Raft and a couple of other concepts you probably know from distributed systems. And that makes it possible to have this kind of technology, not only for the problems. Normally people think, when I say workflow engine, they think of, oh, human task management. You do that 10 applications per day. And that's not what we do. I mean, already today I know a lot of customers doing like Zalando or T-Mobile or whatever, they're doing huge scenarios on workflow engines, really a lot. But we're really aiming for even the high throughput, low latency use cases there. And I think that's very valuable because state machines are truly useful, and let's go back to that. Yeah, that's kind of how fast we are. And the language matters, actually. So I'm a huge fan of BPMN. I briefly, the graphical models I showed, this is BPMN. It's an ISO standard. It's a really cool language to define these kind of workflows. If you're looking at a lot of like other tools, like currently there's a lot going on in the cloud space. So AWS has something like step functions, or we had FN from Oracle earlier on. They have nflow, and Azure has durable function, whatever. There's a lot. Netflix did Conductor, Uber did Cadence, Apache did Airflow. So there are a lot of like workflow engines emerging at the moment. But all of them using proprietary languages. And I think BPMN is really good. It's relatively widespread. It's directly executable, so the XML is not translated into some kind of code. It's directly executed. And it's easy to understand for different stakeholders, and that's what we really see in projects. So I had that operating part. So you can, for example, see how many instances are currently waiting. If there was an error, what's the current problem? You can dive into that. You see context. You see the data. You probably can fix it right away. Or you see that kind of audit thingy, what I showed earlier. So there's a lot of value in that. The language can express a lot of problems. Who knows the Enterprise Integration Patterns book by Gregor Hoppe? Not that much. That's homework, actually, reading through the Enterprise Integration Patterns. That's an awesome book, actually. It defines patterns, how to do integration between certain components within the company. And one of the patterns is, for example, an aggregator. So if you use messaging, not REST, but messaging, you send out messaging through Rabbit or whatever it is, then you could say, like, I want to have this message, but then I have to wait for a second message in order to combine them, and then I move on. And that's, again, normally very often stateful, because the messages might have a delay of probably minutes, or depending on the use case, hours. Or you want to do a resequencing. You say, OK, they might be out of order, the messages, but I need them in this order, so I wait for both and then send them in the right sequence. And everything can always be done with a timeout. So these are all BPMN symbols, like I wait for something, and if it's not done, I do something else. So that's pretty supportive, actually. OK, but back to my state machine problems. So we had the payment, we had the credit card. We cared about network errors. And we had that stateful retry, right? That's what we just did. Now let's look at a very interesting problem. So let's assume the stateful retry gives up. Because after a timeout, like whatever, 10 minutes, 15 minutes, an hour, or like you said, you retried it 20 times, now I give up. I raise a payment, failed. It's not going to happen, right? So that's relatively common to do, right? OK. We still have a distributed system. One characteristic which is really ugly in a distributed system is this. So if you make a remote call, let's consider it REST for the moment. You do a REST call, and you have a client and a provider. You're doing the REST call, you get a network exception. You have no idea if that failed on the way to the provider, if it reached the provider and the provider exploded while he's doing it, and then you have no idea if it committed to a transaction or not, or if it done everything properly, but the response got lost. There's no way of really knowing this. And the same is true if you do messaging. You send out a message and you never get a response. You have no idea what happened, right? And that's a problem. Let's assume this case, right? You charge the credit card, you give up, you raise a payment, failed. If you haven't done the zucchini part, the idempotency, you probably even charge the credit card multiple times because you retried it, and then you give up. That's really bad design. If you do the idempotency correctly, there is a chance that you charge the credit card. And you have to think about these cases. You have to clean it up. The strategy can be, like there are different strategies. Probably you want to send a cancellation message or refund message or whatever it is. But you have to think about that, especially in this use case. Some use cases allow that you just ignore the problem, but very often you have to care about it. And again, it has to be stateful, because if that's already really faulty there, the risk that the refund go through immediately is relative. The chances are relatively small. Okay. And then it's really good to know what's going on. That makes a lot of sense, right? Okay. Talking about synchronous communication. Who is using a lot of synchronous communication? REST, gRPC-like things? Who is using asynchronous communication? Messaging? Kafka, anybody? A couple of Kafka people here. Kafka messaging was quite even. REST was a bit more, which is kind of the normal thing that happens. So if you're not doing synchronous communication, and I think this HTTP 202, that's the first step towards asynchronicity, and I think it's a very important thing to consider. If you look at asynchronicity, I mean, the problems are, and this is my favorite quote for that, synchronous communication is the crystal meth of distributed programming. It's like everybody knows it's bad for the architecture, probably, but it feels so easy, and I don't have time in that project. Just do it the last time, and the next time I've given up, right? If we look at asynchronicity, the problems are comparable. So you have things like you probably send out a message, then you wait for the response, and then you want to have a timeout doing something. So that you can do that. Or even do more complicated stuff like waiting for the response. And this is like, if it doesn't happen, then I do something additional, like the retry. In this case, it's an asynchronous name. And if it doesn't happen within a certain time frame, I do something else. So this is, you can take care about timing. That's actually really important. One pattern I came across relatively often, actually, and the last time was a cloud CRM system. What they did is they used Rabbit in this case. They had a service in Go that used the database, and they wanted to consume the message. Then they did some business logic and changed something in the database. Then they wanted to send a response message back. And that should happen as quick as possible because they had a client waiting for that. And then they wanted to fan out some additional events, like for other components, this has happened. It's important that these events happen because otherwise it gets inconsistent. But they don't want to wait for it. They want to send the response as quick as possible. And that was a problem for them. And they invented like a horrible complex thing there where they said, we write the events in MySQL in this case, use Debezium, which basically leverages the transaction lock of the database, reads that, and generates event from that later on, which is kind of a really horrible thing you have to maintain yourself. So what we ended up with a simple workflow, actually. And we said, OK, when we receive the message, the first thing we do is we do the business logic. And you're transactional in a way that when you act the message, the workflow is started. We support, for example, in C, we support idempotent start, so you can do that multiple times. That doesn't matter. And then we do every step like transactional. And that means we do the business logic, we send the response as fast as possible, but then the workflow engine will make sure that the events are emitted. That's easy to understand. So these are relatively low-level use cases where you need stateful things actually to solve these kind of communication problems. And they're everywhere in distributed systems. We are moving towards distributed systems. You will have them in a lot of cases. And then you shouldn't build your own stuff, actually. That's from one of the projects I one of the technical guys, that's what he wrote. So they basically build something themselves. I see a lot of people building something themselves. I wouldn't do that. Anyway, last thing, and yeah, that should be doable. Last thing I want to quickly look into, which is orchestration, which is basically gave that talk a name. And if you look at the orchestration, which is often perceived as that central conductor, which basically orchestrates everything, and then I do certain things in a row. And there is probably, you know the guy, Martin Fowler? Yeah. Most of you, okay. He's quite famous. I mean, he's from UK, he writes a lot of blog posts, good books. He's really good. And he wrote quite a while back, he wrote a blog post about microservices. And there he said, okay, if you do microservices, then you normally favor a smart endpoint and dump pipes approach. So not like a central orchestrating tool, but more like choreographed services. It was a while back, so he said REST-ish protocols. Nowadays, it would probably be eventing or messaging. And that's actually what we see a lot of customers doing. And I make examples, like this is Zalando. They did a talk what they do. And they do the whole order fulfillment on our platform. So I know a bit what they are doing there. And the example is basically motivated by them. So let's assume I do like order fulfillment. And then I have a couple of microservices in order to do that. So I have the checkout service in order to order something. Then I have payment to retrieve payment. I have inventory to care about stocks, and shipment to ship out the stuff. That's relatively easy to imagine, I hope. So I have these services. Now they have to play together. And if you do that choreographed or event-driven even, then it would look like the following. So if in order to get that workflow done, checkout probably emits an event. Hey, I received an order. Payment gets that, says, oh, there was an order received, I have to retrieve payment. I received payment, then inventory knows, oh, payment received, so I have to get the stuff, and so on and so forth. Right? That's basically the peer-to-peer communication. That's what a lot of projects now do because they want to avoid any kind of orchestration. I see that happening a lot. The big problem is you don't see the overall workflow anymore. Like you don't see what's happening. It's hard to understand why the workflow is really, why the goods are delivered. I was really happy when I saw Martin Fowler's blog post on this beginning of last year. He also wrote that. He said, the danger is it's very easy to make nicely decoupled systems. Yeah, that's cool with the notification, but without realizing that you're losing sight of a larger scale flow, and thus that you're yourself up for trouble in future years. And there are other sources in the internet. If you look up Netflix, or I have a couple of others, they all agree on that. So if you look at choreography, it's normally like this picture is used, like everybody knows what they're doing, and that gets a beautiful dance. And what I see in companies happening is actually a bit different. It's still everybody is doing something, but it's hard to understand, hard to manage actually, hard to control. And that's a problem we see arising a lot. So the alternative, just to highlight that, the alternative would be, and there are examples, like if you want to, for example, change the sequence of things, right? On the right, I want to fetch the items first because I want to deliver faster. In order to do that, I have to adjust 3 or 4 services depending on what I do. And that's really a bad idea there because you have to redeploy them at the same time. That's exactly what you don't want to have with microservices. So you have to extract that. You have to have the order capability in them, for example, in a separate microservice, right? I mean, it's order fulfillment. If you're a Zalando, that's the main thing you do. You should have a service for that. And then it looks different. Like the order service might still check for an event from checkout. So checkout probably doesn't know about order fulfillment, but order fulfillment knows about checkout. But then it commands the others. It says, hey, payment, do that for me. OK, payment did it. Hey, inventory, now it's your turn. And that's orchestration. Right? And you can express that with these kind of workflows. The important thing is it's nothing central. You shouldn't have any payment details within that flow. It's just the overall flow of retrieve payment and waiting for it's done. And then probably you escalate if it's not done, for example. It's always stateful because everything there is remote communication. And that's orchestration. It's nothing central. And it's incredibly useful from my perspective. And then you have to mix choreography and orchestration. And it's nothing central. So if payment also has stateful things, it probably runs its own engine, probably a different product. It doesn't matter. They do that. It's behind the API. It's an implementation detail. But if you have the requirement that you need that state, then you should have like help in order to build it. That's it. That's all I have. So that's the summary. Every way of remote communication has challenges, like synchronous, asynchronous, basically all of them. For a lot of these challenges, you require state handling, or what I call stateful orchestration sometimes. These peer-to-peer communication can lead to problems, so you have to balance orchestration and choreography. That's really important. Most projects miss that. And most strategies are business logic, so the visibility we get from languages like BPMN are really incredible, are really, really helpful. That's it. That's all I have. I will put up the slides afterwards. Thank you, yeah.